Hey guys, I will be showing you how to balance a redox reaction. So we're given, consider the following redox equation in aqueous basic solution. N2H4 liquid plus BrO2 minus aqueous goes to NO gas plus Br minus aqueous. So the first step is to ask ourselves, what is being oxidized or reduced? So to do that, we need to assign charges for each atom in the redox equation. Alright, so starting with N2H4. We know that hydrogen has a positive 1 charge, and since there are 4 hydrogen atoms, it has a positive 4. And since the overall compound is neutral, nitrogen has to have a negative 4 charge. So the charge of nitrogen, a single nitrogen, is negative 2. Next, we will do BrO2 minus. Oxygen has a negative 2 charge, and since there are 2 of them, I don't know if you can see that, Br2, there we go, a negative 2 charge. So, since there are 2 oxygens, it'll have a negative 4 charge, and due to this negative charge of the overall compound, bromine will be positive 3. Next, we'll move on to the product side. NO. Oxygen, once again, has negative 2 charge, so nitrogen has to have a positive 2 charge to cancel out because the overall charge of the compound is neutral. And Br minus is just negative 1 because there's only Br. Next, we'll look at what's gaining and what's losing electrons. We see that nitrogen in N2H4 has the nitrogen atom first has a negative 2 charge and then has a positive 2 charge. This means that it's losing electrons, so it's being oxidized. So all of the compounds of nitrogen is part of the oxidative half reaction. And bromine first has a positive 3 charge and then goes to a negative 1 charge, which means it's gaining electrons because it's becoming more negative. So, since it's gaining electrons, all the bromine is being reduced. So, let's write them up. For the oxidative half reaction, as I said before, is everything with nitrogen. So let's write that down. N2H4 liquid goes to NO gas. And let's balance what we have so far. We have 2 nitrogens in the reactants and 1 nitrogen in the products. So let's multiply NO by a coefficient of 2. Next, we're going to be balancing by mass. We'll start with oxygen. We have 2 oxygen atoms in the product, so we need to add 2 waters in the reactants. Next, we will balance the hydrogens. In the reactants, we have 4 here and then 4 here. So we have a total of 8 hydrogens in the reactants and 0 hydrogens in the products. So we will be adding 8 H pluses. Next, we will balance by charge. We have so far a neutral charge here, so a charge of 0 in the reactants, and a positive 8 charge in the products. And we'll cancel out this positive 8 charge by adding 8 negatively charged electrons. Okay, now we'll do the reductive half reaction. The reductive half reaction is everything that has bromine in it, because bromine is the one that's gaining electrons. So let's write down everything with bromine in it. That is BrO2 minus goes to Br minus. Don't forget the states. Okay, so since we have an equal amount of bromine, we'll move on to oxygen. We have 2 oxygen atoms in reactants, so we need to add 2 waters in the products. Next, we'll balance the hydrogens. We have 4 hydrogens in the products and 0 hydrogens in the reactants. So we'll add 4 H pluses, and to balance the charge, we'll also add 4 electrons. Great, now you have both the balanced oxidative and the balanced reductive half reactions. So to write the overall redox reaction, we need to multiply each half reaction to get an equal amount of electrons. So in the oxidative half reaction, we added 8 electrons to the products, and in the reductive half reaction, we added 4 electrons to the reactants. And in order for these two numbers to match up, we can multiply the reductive half reaction by 2. So, in the balanced redox reaction, we will just add the oxidative and the reductive half reactions. Alright, so for the reactants, we have N2H4 liquid plus 2H2O liquid plus 2 BrO2 minus plus 8, remember the times 2 here, and the 8 electrons. Cool. And then we will write the products. We have 2NO plus, let's move this up a little bit. H plus and 8 electrons plus 2 Br minus aqueous and 4 H2O liquid. Remember that these 2 and 4 are multiplying the Br minus and the waters both by a coefficient of 2. Great. Okay, and next is to cancel out the common things in both the reactants and the products. So, in both sides, we have 8 hydrogens, 8 electrons, and 8 hydrogens and 8 electrons. So we will cancel those out. Next, we also have water in both sides. So we'll subtract 2 H2Os from the reactants and the products. And the final redox equation is just everything that we have left. So the final answer is N2H4 plus 2BrO2 minus goes to 2NO 2Br minus and 2H2O. Sorry, don't forget the states. Great, and we're not quite done yet. We can check our answer by making a table for the elements and the charge. So we'll just make a table. And the elements that we have are nitrogen, hydrogen, bromine, and oxygen. And we will add another row for the charge, just to be sure. Alright, so for nitrogen, we have 2 nitrogen in the reactants and 2 nitrogens in the products. Hydrogens. We have 4 hydrogens here and then 4 hydrogens here. Remember, we will multiply the 2 by the H2, giving us a total of 4 hydrogens. For bromine, we have 2 bromines in the reactants and 2 bromines in the products. In oxygen, we have 4 here because of the 2 times 2 gives us 4. And 4 as well because we have 2 of the NOs and 2 of the H2Os. So if we just combine these two, we also have a total of 4 oxygens. And charge, the only charged atoms that we have on both sides is the BrO2 minus in the reactants and Br minus in the products. So we have 2 of the negative, 2 of the BrO2 minus, so it has an overall -2 charge in the reactants, and 2 Br minuses, so we will also have a -2 charge in the products. Great. So we have the balanced oxidative half reaction, the balanced reductive half reaction, and the balanced redox equation for the overall reaction. And this table checks our answer.